Hello, happy Monday everybody. Welcome back to Lockdown Learning. So this is session number 49, one short of the big half century. And it's a Monday for the live streamers. It's quite a nice day in Newcastle, or Gateshead, which is a bit of a change from late. And I've got a loose plan for today, although actually what I've got planned may not take a huge amount of time. But nevertheless, I think it's worth taking a look at what I've got planned. I also want to briefly sort of talk about the frequency of these sessions and how that's going to change going in the future. Because, as you may or may not be aware, workplaces in the UK at least are beginning to open up a little bit more. And there is a plan at my place of work in Newcastle University to begin to reopen labs so that research can resume. And that necessarily has a bit of a knock-on effect on lots of different things. So knock-on effect on, I expect the amount of time that you at home are going to have available for devoting to learning new things. If your lab is reopening and you want to get back on with your research, then the amount of time that you've got to sit around watching YouTube videos is necessarily going to go down. It also has a bit of a knock-on effect on me as well, because obviously if there are more people in the labs generating data, then that will have a knock-on effect for my unit, for my facility, and we'll have greater demands on our time. And actually, the demands on our time have not really eased up during lockdown, because the data never sleeps, and we've had lots and lots to do just with the data that had been generated prior to lockdown. But nevertheless, if people are in the labs and doing new things, then there will be new demands as well on our time. And as such, I think my justification to myself for keeping up, first of all, 5 days a week, but now even 3 days a week is going to get tougher and tougher. Again, a proposal for you. And I seem to have done this a lot recently, but I think it's a fast-changing world out there, and we all have to adapt and modify as we go along. So today I'm going to do today, and today I'm going to kind of round off what I was talking about last week. But then I'm going to come back on Wednesday as well, so 2 days' time. So the same pattern as we've had for the last couple of weeks. And I'll talk about something new on Wednesday, and hopefully I'm going to try and have that be quite self-contained. And then lockdown learning will continue every Wednesday from then on. So it will be once a week on Wednesdays. And I've kind of made this decision today, so I haven't had a lot of a chance to really think it through in any detail yet. But I think what I would like to do, because of that reduction in frequency, it's going to be quite difficult to kind of keep some kind of continuous stream rolling from 1 week to the next. So I would like to try and have those once a week sessions be a little bit more self-contained than things have been up until now. So whereas even with 3 a week, I've been able to kind of keep a continuous thread going. I suspect that's going to be less easy to do once we're running at 1 a week. And I may do some. There may be some that bridge 2 or 3 weeks, but by and large, I want to try and keep things fairly self-contained, which means by by the nature of that, the things that I will cover will probably have to change a little bit. So, but I've got a lot of planning to do between now and next Wednesday. I know what I'm doing this Wednesday. Between now and next Wednesday, I'm going to have a lot of planning to do to make sure that those individual sessions can continue to have value for people. And that's kind of my motivation in this, is not just like I enjoy doing this. I like the process, and I have enjoyed, while everything's been shut down, I have enjoyed the structure that doing this has given me. And I certainly, from some of the feedback that I've had, I know that that's been true for some of you as well, that having something to do every day at the same time was quite useful during that period when everything was shut down, and structure was really necessary. But what I would like is not just about my enjoyment, right? It's not just about me sitting here and feeling good about myself and feeling gratified that, oh, I've done something that maybe, half a dozen people have watched. It's also about it being functionally useful. There's no point in waffling to myself for an hour a week and nobody finding that material of any value. So I think I do need to put some planning in to make sure that it is of value, and maybe I'm not making any promises, because I think those of you that have stuck around for nearly 50 of these things know me well enough by now that to know that I'm not the slickest and most professional of broadcasters, shall we say, but a bit of planning for once a week rather than very little planning for 3 times a week is probably slightly more likely to be of value. Okay, so with that slightly unplanned waffling aside, I like to stay true to form, keep it on topic. Right, but with that aside, what I want to talk about today is actually the thing which I slightly fudged at the end of the last one. Again, to refer back to my ultimate professionalism in all things, where I tried to load our BCF file into IGV at the end of the last session, having spent an hour talking about BCF tools and how to use BCF tools to call variants in our alignments. I then tried to use IGV to look at those variants that we had painstakingly called over the previous hour, and completely failed. And so I did take some time after the session on Friday to try and figure out why that was, and I'm not sure I've really pinned down the actual reasons for it as much as I would like to be able to say, oh yeah, totally nailed it. I'm not completely convinced I've pinned down all of the reasons why it didn't work in the way that I expected. But that said, I did figure out how to fix it. And so there's a few things to talk about in the context of this. Let's have a think about some of those things as we go. So, right. I'm just tidying up because, and then, sorry, I'm talking to myself here. Okay. There we go. Right. So, apologies for that. Let me bring up my terminal. There we go. So, if you recall, what I tried to do was I wanted to look at the BCF file in IGV, and it failed to load, and it failed to load with a relatively cryptic error message, which is fairly typical of quite a lot of bioinformatics software. What I found out in my in my trying to figure this out on Friday evening was that there's going back quite a long way, you can find issues that people have with interoperability between various interpretations of particularly the BCF specification and newer versions of the VCF specification. And ultimately, what one piece of software calls BCF actually can be subtly different from what another piece of software calls BCF, and that creates complications. And I suspect what's going on is a bit of an incompatibility between what SAMtools and what HTS-lib does and what Picard and the GATK do, although they're dealing in the same formats and they're trying to achieve much of the same ends. They do vary slightly in their implementations, and IGV, as I mentioned when we downloaded it a couple of weeks ago, IGV is developed at the Broad Institute, where GATK and also Picard tools are developed. Whereas the home of SAMtools and HTS-lib has historically been the Sanger, and they do things subtly differently in various ways. And so I think the bottom line is that the IGV just doesn't quite understand the BCF tools, especially the BCF tools compressed BCF file. So I tried several things to try and get this to work, including creating an uncompressed BCF file, a VCF file, which is text, and actually none of these things worked. And eventually I pinned it down to one particular problem, and I'll try and explain what that problem is. So we've got our files from last week. So if you remember, we created several BCF files while we were doing our calling on Friday. So we created our pileup from using mpileup. We created the pileup BCF file, and then we used BCF tools call to create the actual calls themselves in this call file. Then we used the norm tool to tidy up the indels. That was this file, and then our final filtering gave us our variance file. So this was our endpoint for our variant calling last week, and that was the file that I then tried to load in that didn't work. What I found subsequently is that the best format to load in to IGV is actually a VCF file. So is a text file rather than a binary file. But there's one other problem that prevents it from working. So what we're going to do first of all is we're going to make the VCF file, and then I'll load that in and I'll show you what happens with just the VCF file, and then we will figure out how to fix that problem. So BCF to VCF is achieved with BCF tools view. So this is very much like SAMtools view for converting between these different formats. So BCF tools view, if we want to be explicit about it, we could say that we want the output format to be VCF. So that's -O and then V is being explicit that the output format is VCF. We name our output file -O, and that's going to be SRR118666736, and we'll call it .variance.vcf. So that will be our VCF file, and then our input file, which is the final argument for all of our BCF tools, always take an input file at the end. That's our BCF file that we've already got created on disk. So this is the command for converting our BCF file into a plain text VCF file. So that has done that, and then we can use less because now it's a text file. So now we don't need BCF tools view to look at it. So we can look at it using less. So this is our VCF file. And if you remember, it's got our variants in that passed our filters. So we did a filtering step as our final step in the variant calling, and everything that's left in this file then are the variants which passed that filter. So that's what we've got here, is all of those variants that pass that particular filter. Okay, so those are our variants in a text format, and this is a VCF file, and IGV really should be able to understand a VCF file. So let's try loading this in. So if we go to IGV, so I've got running there in the background, and you can see that I've already got my BAM file, my alignments loaded in. If we try and load our VCF file in here, what you will find this time, assuming it does the same as it did last week, is that the file will load. There will be no apparent errors when I try to load this file. So it should load, but what you'll see is it reports in here, it's not actually showing me anything. It says no variants found. And well, when this sort of thing happens, when you have an apparently valid file which seems to load just fine, but the contents in the file doesn't appear in the browser, that is almost always down to some sort of incompatibility in the naming of the chromosomes that you're dealing with. So this always used to happen with the human genome. Still does to a certain extent. You still quite often run across this problem with the human genome, because there have historically been two separate distributions of the human genome, and actually they tally very much with the two genome browsers which we looked at in the session where we looked at IGV. There's the UCSC version of the human reference genome, which is usually preceded with HG, so you get HG19 and followed by HG38, really logically. And they name their chromosomes. Actually, let me bring up my whiteboard because it's easier, rather than describing, it might be easier to write. And I managed to sequester Jacob for an afternoon as well. So so we have a picture. So Disco Chick makes his return, along with apparently Disco Shark, I'm told. So always a delight. Oh, and something else is appearing. Something else that he drew. I didn't see. Oh, this is Rockin' Shark, and it's drawing as he drew it. Really, as whiteboard catches up. There you go. That's Shark with a guitar, obviously. Okay, so always love a picture of the day. So that was Jacob's picture this afternoon. I'm afraid I'm gonna do the heartless thing and get rid. Whiteboard's struggling in various ways. Okay, I'm going to have to do a bit of a catch-up refresh, I think. I'll give it a second and just see if we can catch this up. There we go. Come on, whiteboard. I don't think I've ever been a great advert for Microsoft Whiteboard in these sessions. No. Yeah. Chrome is slightly more reliable than Safari used to be, but it's still not brilliant. Although actually I think this might be a problem on the tablet end rather than the laptop end this time. Let's see if this catches up now. Last time's a charm. Come on, here we go. Just give you obviously the usual thing that's happening. It's taking longer than expected, and the picture's still there. Okay, this is not going terribly well, is it? Dear, oh dear, oh dear. Okay, I might have to give up on this and do this a slightly alternative way. Let's try doing this an alternative way. Right, okay. Never let it be said I can't improvise. Let's go to the UCSC Genome Browser. UCSC. Okay. Here we are, the UCSC Genome Browser. And if we go to the browser itself, then it's going to drop us into HG38. So this is the 38th build of the reference genome, HG38. And you can see that for this particular region in this particular genome, this particular build of the reference genome, the UCSC Genome Browser refers to CHRX. Okay, so chromosome X is CHRX. If we go to the same place in Ensembl, so if we go to the Ensembl Genome Browser and we go to the same region, actually let's just go to ACE2 in human, because that's the gene that we're dealing with. Okay, it's on chromosome X, and if we have a look at the location according to Ensembl, which is often referred to, this release of the genome is called GRCH38 rather than just H38. It's X, 15 million, blah, blah, blah. So instead of CHRX, we're looking at chromosome X without the CHR prefix. And this small little detail, in the different way that these two releases of the same object, the same data, this little difference in the way that they refer to their sequence identifiers has over the years led to untold problems with mapping things between one and the other. So if you've aligned your reads to the Ensembl reference genome that you've downloaded from Ensembl, and then you try to view your reads in the UCSC Genome Browser, historically that's been a real problem. Because the chromosome names are different. They're subtly different, but they are different. And that difference means that the genome browser doesn't know what to do with the mappings. It doesn't know what to do with those alignments. It doesn't know how to position them because the names of the chromosomes are different, and that causes all sorts of trouble. And that is a problem which to a certain extent has been overcome. So these days, if I've mapped to HG38 or to GRCH38, IGV, for instance, will be able to understand that CHR1 and 1, or CHRX and X, are referring to the same entity, and they'll be able to show me the reads regardless. And that works for BAM files, but it doesn't necessarily work for every format. And this is one of the problems that we're encountering here, is that we have in our reference genome, so if we go to our VirtualBox and have a look at the reference genome, here we go, our chromosome, okay, is called NC underscore 000913.3. Okay, that is the name of our chromosome. It's the first word in that sequence header line is effectively the name of the chromosome. So that's the name of the chromosome in our reference genome. If we look in our SAM file, our BAM file, sorry, you will see that the name of the chromosome carries over into that file as well. So NC underscore 000913.3. Okay, so that's the name of the chromosome. That's in the BAM file as well. It's also in the VCF file. So we saw it before, but if we look at the VCF file, you will see that each variant is placed on that chromosome with that same name. Okay, NC underscore 000913.3. If we look in IGV, the chromosome in IGV is being referred to not as NC underscore 000913.3, but just NC underscore 00913. The 0.3 is missing. And this didn't actually seem to make a difference when we loaded in the reads from our BAM file. So the BAM file loads in quite happily and the reads load up and we see what's going on. So there seems to be at some level, and I've not tracked down where this is, there seems to be some alias that deals with the missing 0.3 in the name of the chromosome in the IGV representation of the genome, because the BAM file loads up just fine and we see the reads exactly where we expect to see them. This translation, however, doesn't seem to be happening with the VCF file. So when we load in the VCF file, although IGV understands the format and can load up the VCF file just fine without any errors, what it can't do is then display the variants in the context of this genome, because the variants are all on NC 000913.3. They can't be displayed on a chromosome called NC underscore 000913 without the 0.3 on the end of it. Now, I will confess, I have figured out that this is the problem, but what I haven't figured out is why it is a problem for the VCF file, but not for the BAM file. And I'm sure there's a really good reason why that is. But I've not managed to figure it out. I've not managed to track down that reason. But knowing that this is the problem, I do know how to fix it, which is good. So let's first of all, let's remove the VCF track. So I've right-clicked on the name of the track over on the left-hand side here, and that gives me a little pop-up menu, and I can drop down to the bottom of that where it says Remove Track, and that will delete that track from the screen. Okay, so what we need to do is we need to change the name of the chromosome either in the genome in IGV or in our VCF file. And it's actually easier to do at this point in the VCF file than it is to do it in IGV. So that's what we're going to do. We're going to make that change. And we're going to do it using a tool which we have come across before. And that tool is SED, or the stream editor. So SED stands for the stream editor. And it considers its input line by line and makes changes line by line depending on the patterns that you give it. So you give it a pattern in order for it to make changes, and it will make those changes line by line. So the pattern that we want to be able to make these changes, and we've done this once before, and the way that we did it then was probably just as cryptic as the way that I'm going to do it now. But nevertheless, this is the way that we're going to do it. So we want to do a substitution. Okay, so before we even start defining our pattern, we want to say that we want to tell said that we want this to be a substitution. So that's what the S means. And then we want a two-part expression, the first part of which is the thing which we want to substitute. So that goes between the first two forward slashes. So we've got a forward slash, then you have the thing you want to substitute, then you have another forward slash, and then after that second forward slash, you have the thing with which you want to substitute it. So you've got your search, and then you've got your replace, and then you have a final terminating forward slash, and that's your pattern. And this will replace the first occurrence of every instance of this pattern on every line of your input file. So the thing which we want to replace is the name of the chromosome in our VCF file. So that is NC_000913.3. Okay, so that's the name of our chromosome as it is in our VCF file currently. And what we want to replace that with is the name of our chromosome as it is in IGV, so that the two things are compatible with one another. Okay, so that means that we're replacing that name for the chromosome with the IGV name for the chromosome, which is exactly the same, but missing the 0.3 on the end. Okay, so the first bit here, this is our search. From the first forward slash to the second forward slash, that's the string that we're searching for in our input stream. Then this is the thing which we're going to replace it with in our output stream. So just removing the 0.3 effectively. And then we need an input stream. So the input stream is going to be our VCF file. Okay. So just to test that this is going to work, I'm going to allow this to print its output to standard output. So I'm just going to run it so that it prints its results to the screen. So there you can see at the beginning of every line, instead of having NC000913.3, we now have NC000913 without the 0.3 at the end. So that is behaving as we expected it to behave, which is promising. So in order to save this, we want to write this to a file. I should also say at this point, actually, and this is worth thinking about at this point because this is a good stage to do it. BCF tools, which has a lot in common with SAM tools because they're both part of what's called HTS-lib, so this set of libraries for working with high throughput sequencing data. So BCF tools, in common with SAM tools, for almost all of its tools, will print its output to standard out. So it will allow you to chain your tools together, taking the standard output from one tool and passing it into the next tool as standard input. Because as well as all of the tools producing their output to standard out, they're generally able to read their input from standard in as well as from a file. So just by way of example, if we think about the little script that we wrote while we were doing our calling on Friday, sorry, in session 48, we wrote these different commands as individual lines, so one line at a time, basically. We could actually have done this as a little string of piped together commands. So we could have done BCF tools mpilup and then all of your various options for mpilup. But then rather than producing an output file, we could have piped that into BCF tools call, again with all of the appropriate options, and then piped BCF tools call into BCF tools norm, and then taken the results of that and piped it into BCF tools filter. And only at that point would we have needed to write an output file. So you could srr 118 -o srr 118 66736 dot BCF. So we could have easily constructed this pipeline by way of using the pipe character and chaining one tool, the output from one tool into the input for the next tool. And actually, this is quite an effective way of doing it, because you're, instead of producing your results on the disk, you're producing it in RAM, and it's all quite rapid. So that would have worked quite nicely. I'm not going to worry too much more about that right now. What I'm going to do instead is just pipe. So we did previously we did BCF tools view, and we put that into an output file, this VCF file. But what I'm going to do instead is I'm going to, so this BCF tools view command will produce the results to standard output, and then I can pipe that into sed. So and then my sed command is as it was before, so s/nc underscore 000913.3 /nc underscore 000913 without the 0.3, close your single quotes. And so this will take the standard output from BCF tools view as standard input to sed, and then sed produces standard output, which we can redirect into our variance.vcf file. Okay, so just exploiting that ability of BCF tools to produce its output to standard output, which is actually a extremely useful and to a certain extent underrated means of kind of shunting things around at the command line. Right, okay, so that's that. Away it runs, and that produces us our VCF file now with the chromosome name changed so that it's compatible with the chromosome name in IGV. And now when we load this file into IGV, which we will do, file, load from file, and here is our VCF file that we've just created. When we load that in now, we should see our variance popping up. So now it no longer says no variance found. So it's read the VCF file, it's understood it, and it's now displaying our variance in this VCF track at the top. And again, if we click on the variance, we're going to get the information. So this is giving me the information from the VCF file about this particular variant. So the position on the chromosome, so about base 1, about 1.5 million. The reference is an A, the alternate is a T, and it's a single nucleotide polymorphism. It's not filtered, it's a pass filter variant. Got one alternate allele, so therefore two alleles at this position. It's got good quality, good, nice high quality. The various depths of everything represented here, as well as lots of other information. So we can zoom in on that a bit closer to that particular region, and you can see it's an A in the reference genome, all of our reads at this location have a T, pretty much anyway, and the variant is absolutely reflecting that. And if we wanted to scroll through our file to find more variants in more positions, we can do that. And so here is here's another. This is a C to T change with very high quality, presumably because everything in the alignment is. So all of the reads mapping to this location are T's, and this one T to C change, again very high quality variant, and so on. So all of the information that's in our alignment is kind of transferred across to the VCF file in some way. It would be interesting to find a place where you can see variation in the alignment where maybe a variant hasn't been called. And I'm sure if we scanned for long enough, there we go. So there's two examples where you've got variation in the alignment. So here the reference is T, and most of the reads that map to this locus are T, have a T in, but there are a significant proportion that don't. So around 20% of the reads that map here don't have a T. Yet this has not been called as a variant, and it's not been called as a variant because we were only interested in haploid variants. So when we weren't interested in these potentially subclonal variants, or maybe this is a result of some sort of sequencing error or PCR error. But either way, this is a variant because it's not even close to being homozygous, this variant. It's been eliminated in our variant calling at one of our stages, presumably at the filter stage, but maybe earlier than that. It may have been eliminated by the calling itself. So yeah, that's what we can see here. This position, this variant here is very similar in that regard. It's an A in the reference genome. There are a small but significant minority of the reads which map to this position, which have a different base, therefore this particular variant has been eliminated by our variant calling. I would suggest actually that this pair of variants in tandem is actually relatively interesting, but isn't. There's a reason. The reasons why they haven't been called are perfectly valid, right? So I understand why they've not been called. What's interesting is how often these two variants co-occur in the same read, although actually it's not quite as consistent as I thought it was going to be. So the thing that I found striking was that the numbers here were very similar. So it's about 20% of the reads contain the alternate allele. And therefore what I thought might happen is that what we've got here is an alternative haplotype, effectively, thinking in kind of human speak at least, that where this run of bases isn't TA, it's in fact GG, which you can see in this pair of reads here, right? So this read has the G at both positions, and this read underneath it also has this G at both positions, which suggests that that's a mutation. It's a mutation that's coupled, that where if you don't have the TA, then you have the GG, and it's an alternative haplotype. So maybe it's a subclonal population which carry both of those mutations together. But actually, there's a decent number where an individual read only actually carries one of those changes. So you can see an example of that at the top here, where this particular read only has the G at the second position, doesn't have the G at the first position. And here's one which is the other way around. It has the G at the first position but not at the second. And then here again, this is at the second but not at the first, and so on. So there's enough, although quite a lot of these are coupled, it's not completely universal. And so actually it may well not be the case that that's a subclonal population of bacteria, and that actually it's maybe not quite as interesting as I thought it might be at first glance. But this is the kind of subtleties in variant calling that can be very, very hard to account for. They're difficult to account for in bacteria, where you've got a relatively simple genome and in theory a relatively clonal haplotype, a relatively clonal haploid population. In humans particularly, which is where an awful lot of variant calling effort has been expended, obviously you're dealing with a diploid organism, so you've got 2 copies of the genome going on in most situations. You've also got a genome which varies within the individual as well. Germline genomes and somatic genomes vary, and depending on where your sample is from, depends on how much of that kind of intra-individual variation you can expect. And it's all of these factors are what make variant calling a really quite tricky proposition, even in these relatively simple populations. But anyway, that's kind of, as I said, I wasn't entirely certain that today what I wanted to do today was going to take a huge amount of time, and it kind of hasn't really. That's what I wanted to do, is to be able to view that VCF file in IGV, and we have managed to achieve that. So, and again, that's falling back on our command line tools, right? So that's going right back to the very beginning of these lessons, and the reason why I started where I started teaching these command line tools is because so many of the formats that we deal with in genomics especially are text-based formats, and the command line Unix tools, these really old school tools from the 70s, are really, really, really good at working with text. They're fast, they're flexible, they're efficient, and there's no sense in re-engineering that. So there was a reason why I kind of that's where I started, and that's what we will come back to, and we will come back to those things, I think, relatively frequently, because they have so much utility, because they are so powerful and flexible. Okay, so that's where I wanted to get to today, and I will be back in 2 days' time with session number 50. So that'll be on Wednesday, the 17th of June. Half century, which is a fairly remarkable landmark that I didn't think I would get to. But after Wednesday, we will proceed with one session per week from then on. Okay, so what I'm going to do to begin with in those slightly more self-contained sessions is I'm going to do a couple of technology tutorials. So on Wednesday, I'm going to talk about Git and GitHub, which has come up relatively frequently over the last few weeks, and it took me a few weeks to do it, but I instigated we got a GitHub repository up for these lessons, and the code that we've written as we've gone along has been submitted to that GitHub repository, and I've just put it there and not really said very much more about it. So what I'm going to do on Wednesday is talk about the technology that underlies that. So I'm going to talk about Git and version control, and I will talk a bit about GitHub as well, and how to use GitHub. And version control is a really important topic, and is, if you're going to at any point write any of your own code in anger, then understanding and knowing and using version control is really important. So that's going to be the topic for Wednesday. And then the week after, I think I'm going to stick with a technology tutorial. I'm going to talk about a workflow management system. So I haven't quite decided which one yet, because I've tinkered with a few, and I've never really settled on one to use myself in to a huge degree. And so I'll talk about workflow management system. It will either be Nextflow or SnakeMake. I just haven't decided which yet. I like both, and both have their strengths, but I'll make a final decision on that before the following week. So that's the next couple of weeks, and I think I'll do a few of those kind of technology tutorials, because they're quite self-contained, and then I'll think about looking at some other bioinformatics technologies as well, obviously during that time. But these kind of technologies are all part of kind of doing bioinformatics, undertaking bioinformatics, and being a bioinformatician. So I think they're just as important as the how to fit slot tab A into slot B kind of here's how we analyze this particular kind of data type tutorials. Okay, with that in mind, one last thing before I sign off. I mentioned ads and monetizing last week, and I just wanted to let you know I have switched the monetization option on all of the archive videos other than the last 2 weeks, and that my plan is always to keep videos ad-free for at least 2 weeks before adding ads onto them, just so that you know that going forward, like, I'm not going to be completely spammy about my advertising. And as I said before, any proceeds which I do make, which I think so far over the weekend was massive 20 cents, will be donated to good causes. So I'm not going to be personally profiting from the adverts on my videos. Right, okay, that's all said and done now. I'm going to sign off, let you get on with your Mondays, and I will see you all on Wednesday for what is essentially the first weekly lockdown learning. So our new paradigm begins on Wednesday. So see you then. Thanks for tuning in, everybody. Keep safe, stay well, and see you next time. Bye.